All right, so we're already at week 10. Spring is on its way. Warm weather soon, hopefully, someday. Maybe, possibly. I don't know if it'll ever happen. Starting to lose hope. But we have a discussion board this week. So this week's discussion board, I want to make sure you look at it. And so now that you guys are all experienced programmers, we've been doing it for weeks now. You're good. You're ready to go out on the job. We have a list of sites, and there are certainly more than these that have challenges and different coding challenges. But what I'd like you to do is go take a look at these, at least a couple of them, and look at them and evaluate them in terms of, hey, what can I do? Now, we're going to add to your skills again today, but there's also a lot of solutions posted at those. So it's kind of fun to go in and look at how did they achieve a very quick solution. How did they come up with that? And so one of the great things that Python is used for is Python is used for writing very short, very quick programs in a lot of cases. So companies like Google use it to run analytics, or they solve a really quick problem by using something like Python. Security researchers use Python because it's a really great language. We can pop in and write some code, and we can do some security analysis. It's also really good. Data researchers use Python. Python could be used to interface with other languages and other systems like R, and we can actually do data analysis using Python. So we're starting to get there. We're starting to see some of the power of it. And again, we can create really quick gambling games if nothing else. So we're going to get another gambling game, and we're going to start looking at some additional pieces today. So we're going to take up chapter 4. I need to go over a solution for last week's problem, and I think I have about everybody graded. I stayed up until Sunday night until probably 2 in the morning working on those. So there are a few that are probably not graded in here, but as I was grading stuff, I tried to come graded as kind of first come, first serve, and as anonymously as I can as I go through there. So there were some really clever solutions for our coin flip program. And so we'll take a look at some of those methods and different pieces here in just a little bit. But first I want to talk about chapter 10, or chapter 4. So week 10, chapter 4. So if you will flip in your book to chapter 4, chapter 4 starts looking at the idea that we can use strings. So in other words, not just a single character, but we're going to use that string, and we're going to create something new. And we're going to create something called a tuple. You're like, well, that's a funny word. And if you're in a database class, you may have heard the word tuple before. But my guess is most of you haven't. And so we're going to look at how we can combine things. We're going to add our friend. We had looked at him before in pseudocode, this idea of a for loop. So we set a definitive number of loops. And we're going to look at how we can do that. And then we're going to look at some indexing and slicing features. So I'm going to bring up our friend idle again. And I have had some people comment that, are there better editors, or ask if there are better editors for Python? And the answer really is yes. And in fact, on the lab computers, we have an editor that works actually better in some ways. If for no other reason, when you have an error, it actually will tell you what lines, and it numbers the lines. It also has some built-in predefined functions. But I want everybody to get comfortable with the idea of the coding before we hand you a tool that will hide some of the easy-to-find mistakes. So I'm going to create a new file. And one of the things I noticed in about half the people that turn things in, make sure that you put in your name and the assignment in those comment tags. If you don't do that, when I download them in bulk, I have no idea whose assignment it is. Because what I want to do, ideally, is go in and grab everybody all at once, download them, and then I can run the code. So I'm going to put in, just by habit, and I'm going to put in chapter 4. Strings and things. The other thing we have to be careful of is we almost always want to end our program with that open input. And that open input seems silly because it just holds it open, but I'll pull up a program and we'll actually take a look at it, and I'll show you why that it's important. So if I bring up a program from last week, and so let me grab one here. So here's our mood computer that we looked at. And if I just double click and run it, it actually is going to pop up in this window. So I didn't open it in idle and run it. I actually just ran the program directly. And when I run the program directly, and the reason I don't is it's very hard to see the black and white text, but this is how it would actually look if I just ran it. But notice where it says press the enter key to exit. That holds that open. If I did not do that, in the default method when it runs, it's going to just run through and close immediately. And all you're going to see is a text box pop open and close. And that's not going to do us any good. So, in fact, I can show you that if we take this program and we edit it. With one of them. And I take out this bottom input. And then I save it, and I run it from in here again. So now if I run it, all that happened, and unfortunately it popped up in the other window, and I have the two-screen setup, it pops up this text box and immediately closes it. It doesn't tell me if the program ran, what goes on, or anything. Now from inside of idle, if I run it, notice it pops inside of the idle shell still. And so it just hangs around because I don't have that endpoint. But so that ending is actually very important. So just out of habit, again, you can create a template that's got these items in it, and then you always have them when you're ready to begin this. So let me get all my screen out of the way here really quickly. All right, so the first thing we're going to look at is we're really going to introduce you to a for loop. And that we've looked at them before, but a for loop says everything inside of my loop is going to run a definitive number of times. So I'm going to do something here. So I'm going to say word equals input. Please enter a word. So, nothing we haven't done before. We're going to take a variable we've called word. We're going to get an input. Now, one of the other things I saw a lot of people were doing was they were doing that integer function on all different kinds of stuff that it needed to be done. An integer function is great if I want to convert it to an integer. If I really need it as a string or a character list, then I want to leave it here. So, I want to create a for loop, and it's really hard. I'm going to say for. Now, this is where it's kind of interesting. I'm going to use a variable, and a lot of times we use x's or y's, but I'm going to call this one letter in Word. Python is really powerful, and it can say, all right, here we're going to create a variable that's equal to the length of Word. And I can actually then print out so we'll take a look at this. This is kind of a cool little program. So I'm going to save it. File, save, somewhere, wherever it happens to want to save it. Not there. Have it in my Python folder. I'm going to call this chapter 4, and I'm going to run this. And I'm going to enter pretty slick. And that's off of a couple of lines of code. So we can manipulate that word pretty easily. And I think that one shows how powerful it is. So it took instead of being a number, it said, all right, I recognize that you're using that as a character string, and I made that for loop to go all the way through there really, really easily. So Python, in other languages, we could do this, but it is a lot harder to do in most languages than that. I'm going to put my space in there because that drives me crazy. So, and we can try it again. So we can say, all right, let's run it, and let's put in a different word. And I'm going to put in an entire sentence, so let's take a look and see what happens. And notice it says Peru State College, and it puts it in there. And notice it does think of that blank as a character in there. So at the bottom then of page 89, we talk about the for loops and how they work. So in this case, instead of using a number, it actually can work through the for loop using the number of items in our string. So that's a really handy way to do that. So Python is one of the more fluid looping systems we can use. So other programs may not be quite as easy to do that with. So we're going to look at some other functions here. So I want to look at another function we have that uses our loop. So I'm going to delete this right here in the middle so I can just start over, leaving my formatting. So I want to introduce and look at another one. So I'm going to type in for. So we're going to start a for loop. So one of the really common ones, we use I or X or something else. So we use a very common variable. And if I say a for loop and I see for I equals, I know that that one's a variable. It's not very self-documenting, but we know that we use it a lot. And I'm going to say in range 10. And then notice we have our colon at the end of a for loop, so it brackets us down. And then I'm going to put in a print statement. And I'm going to print that value of I. All right, so right now, we have for I in range, and we're going to print I. And so let's see what happens if I run this. So run module, and it's going to want to save it, so we just overwrote what we have. And so it prints 0, 1, 2, 3, 4, 5, 6, 7. And so if I look at this, when I say, well, what is this end? So that's just printing another variable. So you're printing I, and then you're printing a space. Does that make sense? And then we're just looping it over and over again. So we could change this. You could take that out. And I encourage you to do some experimenting. See what happens. If I take this out, and I just print I, so it does. It prints this direction, 0, 1, 2, 3, 4, 5. So we're just changing a little bit of how something looks is all we're doing. So end equals, all right. So we know we can print, so in this case, 1 to 10. So for I in range to 10, we'll run it. And we know that we print 0, 1, 2, 3, 4, 5, 6, 7, 9. So we have 10 variables, but we only print 1 or 0 through 9. But there's 10 variables in there. Well, we can get around that because maybe what I really want to do is print 1 to 10 or use the numbers 1 to 10. So there's a couple of ways we can do it. So one of the easiest ways is just to add that 1 in. So now if I print it, it prints 1 through 10. So not a lot of change in my code, but I can do some other things with this that are pretty nifty. So my for loop doesn't have to just work so that I in range is kind of like on our random range, the same idea. So we can put in, I want to go from 0 to 50, and I want to do it by 5s. And if I do that, I'm going to cheat and grab this right up here so it'll print it out for me. Copy. So now we can run this. And now it printed something really weird. Oh, I know why. Hold on. I put that I plus 1. So we really wanted to count by... Now we'll do it. So now we have our original 1 through 10, and then we have 0 through 45. So it counted in that range. So we might have to do some tweaking to get exactly the right value that we think we need. And I didn't put an extra print statement in there or any way to put a line range in there. So if I can do it by 5s, let me think if I can do it by a negative number. And so if I do it by a negative number, I have to change this a little bit. So I'd have to say from 100 to 50 minus 10. So if I run this now, so it counts up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 90, 80, 70, 60. So we can count up and down very easily inside of those for loops. And it's a pretty easy structure. So we say for some variable in a range of, and then we have beginning, end, and by what increment. So not hard at all. So we can count forward, we can count backwards. And so page 92 and 93 talk a lot about counting by different functions. So we can change these to make any kind of structure we need. So notice when it says 100 though, when I look at that result, let me get rid of some of this junk over here. So I wanted to count from So I wanted to count from 100 to 50, and I'm taking 10 off. Notice it takes that 10 off first. So when I run it, so that's where this experimentation gives you those results. So we have 100, 90, 70, 60, 40. So if I wanted to count all the way to 0, I'd have to change this. So I'd say to 0, and maybe we're doing a countdown for... And so now I count all the way down to 10. But notice I don't get all the way to 0. Even though it says I'm counting down to 0, notice where it stops. And so to actually get that last 0, I would have to do something very clever or look at my code a little bit. So you always want to try those and make sure it behaves exactly. There's always some little quirks inside of there. And you don't have to use it just for this purpose here at counting down. So we could do, for I in range of 10. So let's just do 10. And you don't have to do anything really fancy with it. You could do, you just wanted to print the phrase, spring should arrive soon. And I want to print it 10 times. I can do that in my loop. Spring should arrive soon. And so now we've got at least a couple of ways that you could do that kind of operation. So on page 94, we introduce you to something called the Message Analyzer program. Well, and the Message Analyzer program really is the beginning of us starting to manipulate these text strings. And so one of the first things we're going to do the first thing we're going to do is we're going to create a system where we can look at the length of it. So we have some functions we're going to incorporate. And so I'm going to create an input statement, and we're going to call it so message equals input. Please input a message for your advisor. Because it is about time to start registering for classes, so maybe you want to send in a message to your advisor. So we can do a couple of things, and I like to separate them, but in our book they put them together, so we'll just do it that way to start. So we're going to print, we're going to move it down a couple of lines, and we're going to print the length of your message is, and then we're going to introduce that length function. So length, just len of, and we're going to pass in the value in message. And so since we're passing it in, we have to open and close those parentheses, and then we'll close the outside parenthesis. So right now, we're going to get a value in. Somewhere I probably misspelled something, or I used hit the wrong key up there. Okay. So enter a message. I need to enroll in fall classes. And it's going to say, all right, so the length of your message was 32 characters. And clearly I have some kind of an issue with that line also. But so I know that my length of that whole thing now is 32 characters. All right. Are there other things we can do with this particular code? So there are some other things we can look at and we could possibly add in there. So we may want to figure out what letters are in there. And so in a lot of other languages we could do this. We'd have to sequence through that entire string. In this particular language, in Python, we just say, so if E, because we want to see how many E's are in your message, in message, and then we're going to print E is in your message. So we're just looking for one particular letter. We'll do an else clause in there. So else print you do not have an E in your message. So this very easily is one of the cooler things in Python. So it takes whatever is in that string and it searches through it to see if it's in there. So let's see if it works. So I need an appointment. And so clearly we know that there's an E in there, so let's see if it can find it. And it says E is in your message. Tells me that how long it is, so I have 21 characters. E is in your message. So, and it can search for more than just a single character. So I could look for EE. And so if I did this and I ran it again, and I just put I need, it says, yep, it tells me how many characters, and it would default to true. I didn't change my message, but it's obviously looking for that. And you could try other letters if you wanted to experiment with it a little bit. And so what we're really looking for is we get a couple of pieces. We know how long that length is, and then we also see where if something is in there. So handy, easy way to search through something. If we have a whole string of text, we can search through it really, really easily. But what we're hopefully getting to is we're starting to see that string, we can do some things with that string, and we can maneuver it around a little bit. And so we want to look at how can I access that string individually? How can I look at individual pieces? Maybe I want to do some error correction. Maybe I want to create a game out of it. And so I'm going to do a couple of things here. So I'm going to change this a little bit. And one of the things I'm going to do is I'm going to go ahead and import my random function. Because that random function is pretty handy. And so I'm going to get rid of this. And so now I have some fresh code to work with. I imported my random. And I'm going to say I have a variable named word, and I'm going to equal that to the value right now of index. So we're just going to use this as kind of our test case. And we can certainly print out our word. Word is so that will take that, show us that word is actually created. Great. So we can also look at a couple of other things. And so I want to look at the length of this word. So I need to think about how I can do this. So I can create a variable. And in this case, I'm going to create a variable called high. And I'm going to call that the length of word. But I want to do something a little different. So I also am going to call one low. And I'm going to call that the negative value of the length of word. And so I can print both of those just so I can double check. So I'm going to print high, low. And I'm only doing that just so I can test and make sure that it actually is going to function. So I'm going to save this. And apparently I typed random wrong, which is very possible. All right, so what have I got there? Import. There we go. Changes color on me. There, we can run it. All right, so it runs and it says the word is index. All right. And it says 5 and a negative 5. Nothing that we wouldn't expect. We know that word's 5 characters. And now we can have a positive value and we can have a negative value. So all we did was we got that length. And so I'm just going to mark this one out for now. So now that one won't do anything. And I want to get out some random pieces of this word. So I'm going to create a for loop. So for I in range 10. And I'm going to create a variable called position. And I'm going to set that equal to random.randRange. So nothing we've done new, except I'm going to pass in that variable I created for low and for high. So I'm now going to create a random variable between, in this case we know it's negative 5 and positive 5. So we're going to get a set of values. And then I'm going to do a print statement. Word. And I'm going to use the square bracket. And that's where it gets a little bit different. So notice I've got that square bracket in there. And so I'm on the top of page 97. And so that square bracket is going to mean something kind of interesting to us. So that square bracket tells us we're going to use a position argument open that. All right. So we're going to put that all in there, and let me just grab it here so I don't have to retype with my fumbly fingers today. So let's take a look at that. So you have word, position, you're going to tab, and then now, look what I'm doing here. I'm saying word in that position only. Well, that's interesting. So let's see what it's going to do. And it's going to say that I made a spelling error because I didn't put the E in there. All right. So, and now it should run. And notice what it does. It says it randomly generates values. And so word at position 2 is, well, whatever that is. Is that the D? And it actually will then say, these are what those positions are. And we can verify that, and we can say, well, all right, let's do another print statement. And we can actually print word and use the square brackets and put in, say, position 3, close that bracket. And so what you're doing is indexing that value for word. And so we could run this. And so notice here, that's the one we created. This just shows you how we can address those values individually. So inside that square bracket is our index position of words. So where's Excel? There it is. So sometimes it's easier to think about it if you think about a giant grid like Excel. Let me make that a little bigger so you can see it. So our index starts at 0, 1, 2. So in this case, we know that our characters go up to 5. And so we have the letters I, N, D, E, X. So at position 0 is I, position 1 is N, position 2 is D, position 3 is E, position 4 is X. So when we look at our code, we have that length of 5, but do we really go all the way to 5? Do we know what's out in 5? So this is one of the issues we have to worry about, is when we use those indexes, we count beginning on 1. The computer counts beginning at 0. So if I say I have a length of 5, it's 5 positions, or 1, 2, 3, 4, 5. And so we really don't have anything out there at, if we call it number 5. And we can actually see what had happened. So let's go back to our code. And if I tried to get something at index 5, let's see what happens. And it's going to go, oh, no, your string is outside of that range. So that's something we have to be careful of. That computer counts at 0, and we count at 1 to beginning with. And so we have to be a little careful about that. And we can check and we can look at those. The negative ones are where it gets kind of interesting, I think. So here we have -1, and that is our X. All right, so hang on. Let's go back to our Excel spreadsheet. And so we also had -1. So let's see what -1 is, X. And so it's kind of interesting the way that those work. So bottom of page 97 talks about our counting issue. Top of page 99 shows us how the negatives and the positives work. And so it's kind of an interesting argument here. So here is my -5, my -4, -3, -2, -1, and then, so if I put those in the right order, yes, index. Okay. So 0, so if you think about that as a number line, but I can't just flip a negative value. So it's kind of an interesting thing. So 1 here is the same as -4, -2, the same positions, and I can call them. And so right now that doesn't seem to add a lot of value, but you'll see here later on where we actually will use that. But for now, just remember that it's almost like a number line. So you can say, you know, here we go, -5, -4, -3, and if we continued that sequence, notice Word will happily do this for us. So in here is the beginning of our word, and then it will also go left or to the right, depending on which way we have it. So I can't, though, take the position at 3 and say that's equal to -3 because it's not the same value. And so when we start working with mathematical operations, you'll see that actually will come back to haunt us a little bit. So those negative positions are a little weird. And so take a look at 99, and there's a table up there. The negative positions are kind of the weird thing that we have. So I can get into these areas, and I can print out a character out of any of those spots. So if I want to print it out, a D, I could call it by -3, or I could call it by 2. It's the same thing. But I do have a little bit of an issue, or I think I might have. So maybe I want to print in, and I want to change something in here. So my thought would be, all right, I have this index called Word, but I want to change that name, and I want to change the X at the end to something else. I don't like index. I just don't like the letter X. And so my thought would be, now that I can address these by an individual position, what if I just did this? So if I said Word, and I set it a certain position, because I seem to be able to do that. So what if I said Word at position 4, so that's our last value, or X, and I'm going to change it to C. Well, that makes sense that I could do that, right? Because I can call them out and print it individually, so I should be able to go in and change that character individually. So I'm going to try this and see what happens. So, all right, it ran this, and it gave me my value of X. But when I tried to change it, it says it doesn't support this argument. And so one of the things we have to worry about is that these characters, strings, aren't changeable. So our book has a big word called mutability. So they say it's immutable. We can't change it. Well, there are ways we can get around that, but the string itself, I can't change an individual character in it. So one way we can do that is we can put strings together, and we can do some other operations around that. So we'll take a look at some ways around this one little weird limitation. You would think Python, this wouldn't be an issue. We'd have a way around it. And we do have some. So on page 101, we start a program called Building a New String. So we're going to do a program called No Vowels. So No Vowels, and I'm going to start a new one here. We're going to take all the vowels out of whatever message somebody puts in. So we're going to call this one the No Vowels program. And No Vowels, we're going to take whatever we have as a string. So we're going to use these input. We're going to say input. Please enter a message you want the vowels removed from. And then I have to really give this some kind of a name, so I have to assign it to a variable of some sort. And so we'll call this one message. So we did this before, we know that works. We can get our value in. And because we know that we can't change it directly, we're going to put it into another variable, and we'll just call this one new message. And I'm going to set it up as a blank string to start with. So that way there's nothing in it, and we know that it's empty. And we also need to figure out what our vowels are. And so we're going to do a construct. We're going to call this a constant. And so I'm going to put in my variable name as all caps. Now, Python doesn't really recognize this as a constant. Python says it's a variable and it's got all caps. Doesn't care. And we're going to put in, though, all of the variables that we're going to need. So A, E, I, O, and U. Now, what we don't have in here is any way to tell if this one is, if Y is a vowel or not. So we're not going to worry about that necessarily. So constants can create a little bit of an issue. We just have to be sure that we know that this is a constant. Nothing else is going to do that. So we're going to do a for loop just like we did before. So we're going to use letter, just like we did before, in message. So this is going to loop through as many times as we have letters. So in this case, whatever we put in, it's going to loop through that many times. And we're going to do an if statement. So if, and we're going to use another function that's pretty powerful here. So if letter dot lower, and that letter dot lower says we're going to convert it to lowercase. Because remember, upper and lowercase are different. So we can look, and then we're going to say not in vowels. So what we're saying here is, whatever this value is, if it's not in vowels, then we're going to add it to our new message. So we're taking all those letters one by one and stripping them out, looking at it. If it's not a vowel, we're going to put it into our new message. And so our new message is going to be equal then to new message plus letter. So in other words, we're just adding in one letter at a time in there. And then we're going to put a print statement. Print a new string has been created, and then new message. So every time it loops through, we can actually see that string being created. And then we could go in and we could print it out the whole thing. So we could print your message without vowels is so. Normally, if we were going to do something, we wouldn't have this print statement every time. This just gives us a really quick way we can look at it. We can say, let's see what's happening. And I have something weird there. Probably two of those. All right. So please enter a message. So I'm going to do the Peru State College again. And so as it goes through there, so notice it takes the P, and my misspelling, it takes out the E, so now it's PR. But it also doesn't take out the space. So if I wanted to get out that space, I'm going to go back and change my original code. And I'm going to change that and add a space in there. And now we're going to run it and see if it does something similar. So Peru State College. And now notice it took out not only the vowels, but it also took out those spaces. But so we can't change a string, but I can pluck out items one at a time really quickly, and I can create a new string. So in this case, Peru State College without spaces or E's or any of the other variables is PRSTTCLLG. So that just shows how we can manipulate those strings around. And one of the keys to that is this idea that we can do them in any kind of order and we can randomly grab values out of there. And so the powerful tool we get out of here is those open and closed square brackets. That's that index. So we can put any value in there as long as it's within the value of that string. We can use that length command so we can do that. So it's an easy way we can pull in that information and we can figure out how to do it. So this is an important point about what we're going to do here. We're going to get into slices. So we're going to be able to slice out more than one item at a time. And we're going to be able to create things called a tuple here on Thursday. We'll show you how to do that. What I'd like to look at now is kind of a little more in depth on our program that you should have turned in about coin flipping. So I'm going to build a coin flip program really, really quickly here. Grab that out of the way. So I need my input. Get rid of those out of there for now. So I know I need my name and the assignment. So I have those pieces. Those need to be in there so I know what it is. I need to be able to save this. So File, Save. And I need to know where it's at, because one of the things I saw several people turned in was not the actual program. They turned in like a screenshot or something else. I need the actual program, and so I need to do this as a File, Save As. I'm going to call it CoinFlip. And it's even sometimes a good idea to put your name right in the file name itself, too. Or assignment, some way I can see what it is. So, in this case, I'm going to save it. Well, we know we're going to use our random, so I'm going to put input or import random. And I know that I should probably document as much as possible. So when I go back and look at it and I try to figure out what's going on, this will give me an easy way that I can figure out what's going on. So those imports or those codes and comments are a really great item to put in there. So I'm going to import. I know that a coin flip only has one of two positions. Well, and that's kind of handy because now I can say, well, all right, so maybe I'm going to say coin, whatever variable I'm going to have, is going to be equal to, and then we know we can do our random dot range. And if we do the range, so, and all along here, I can check this out. And that's why I can say print coin. So now I could run this. I could see, oh, does that work? And it says, oh, no, I did the wrong one. So now I have to go back and look at my structure. So 1, 2, from where to the ending. So 1, 2, and I can print coin, so I can run this. So I need to figure out what I'm doing. So I'm like, all right, I don't know. I have a book. But one of the interesting things I can do is I have Google. So I can go, all right, well, here's Google, and I looked for it, and it says, all right, random, and it's got a lot of different, so here's random, rand range, so start and a stop. So random dot rand range. So I can look, and now I can go, all right, let's see, does that work? Yep, I got a number. And I can run that a couple of times and see if it gives me a, yep, gives me that. And I can check that out and make sure that it gives me the values that I really want to get. So I'm going to put a hashtag out in front of that one. Now I'm not going to print that one. And then I'm going to put in here, so I know that, well, I need some kind of a loop. And I probably am going to have a counter. So I'll just call it counter equals 100. We think that's how many flips there's going to be. And so I could say, while counter is less than 100, I'm going to do something. And so what I'm going to do up here is I'm going to say heads equals 0, tails equals 0. So I've got a couple of variables. One heads, one's tails. And so I'm going to put an if statement. So if, because now we're going to flip that coin, equals, and remember I have to use the double. So if coin is equal to 1, and then I'm going to do something, and I'm going to say heads equal heads plus 1, and of course there's shortcuts for that. And so now I'm at the else stage, else. And the good thing about flipping a coin is I know that it can only be one of two states. I don't really need an LF. And I'm going to say tails equals tails plus 1. So I have one other thing I need to do. I need to know that if I'm in a while loop, that I need to have some way to count this. And so I need some way to increment this. So up here, I really need to probably set counter to 0 if I'm going to do a less than. And so right here, I'm going to say counter equals counter plus 1. So this is my loop. It runs. I don't need to print out if it's heads or tails or anything as it's running. But I can. I can make it pretty. And then finally, I'm going to say print heads, and I'm just doing really quickly without making it look very pretty. Heads heads, tails, tails. All right, so here I have a program. It's hopefully going to run. I'm going to push the F5 button to save it and look at it. And it's thinking, and it's thinking, and it's thinking. That's not really a good sign. So I'm going to look at it and go, what's it doing? Why is it getting stuck somewhere? And so I can look at it and go, well, why is it doing that? So I may need to go back in and look at it. I'm not really sure why that one is doing. Control-C will break it. Line 14 in module head equals head plus 1. All right, so it says we interrupted it. We made it angry. I can tell looking at it that there's already an issue. What's the issue with that one looking at it right offhand? I have what? 2 equal signs for which one? Oh. So actually I need 2 equal signs there also. Because remember, equals, a single equals is the assignment operator and says we're making it and pushing it to that value. So if coin is equal to 1, heads equals heads plus 1, tails equals tails plus 1. So when we do the comparisons, we use doubles if we have an assignment value. So let's see if that fixes our issue. Interesting. So obviously there's something else going on here. And so we can comment out pieces and we can see if we can figure out what's going on here. So I took that out. In fact, we don't even need that piece there. So we can eliminate that. So we can look, counter equals 0, heads equals 0, tails equals 0. None of that should cause any kind of an issue. So we can actually stop it right here, and we could comment out this block of code and see if it's in this while loop. So while counter is less, well, looking at this, I see an issue. So notice that I spelled counter wrong. Very simple, easy to do. But because I didn't ever actually change that variable, it was in a loop that would run forever. So now let me try it. And it says heads 100, tails equals 0. Oh, wait a minute. That doesn't seem right, does it? And if you got an answer like this, and some people's code did, I went, all right, let's figure out what's going on. And so the first thing I see, in this while loop, do we ever flip the coin in the loop itself? Where's our coin flip? Oh. So I really need to grab this line here and put it inside of my loop. Because now it'll run inside of that loop instead of just one time. So now I'll save it and see if we fix their error. So we may need to think a little bit about this one. So we have counter, heads, tails. So if coin, so let's just do this so we can see what happens. So print coin. So now we're going to run it, and we put in a test module. And weirdly, coin shows up as 1 all the time. So if that's the case, maybe we need to look at my rand range, and let's see what happens if we change that. So I'm going to change it to 1, 3, just to see what happens. And notice now, all of a sudden our code works. So depending on our statement, we need to always test this and make sure that will work. So now, it doesn't seem to make sense. We go from 1 to 3, but it never uses that 3 value. So that's its upper limit. And I know that seems a little weird, but now our program runs, and it actually works. We have 55 heads, 47 tails, and that seems like an appropriate number. 55, 46. And so you can run that and check multiple times. He goes, okay, so it seems to be working. I can eliminate this print coin. We don't necessarily need that. We can change this. We can do it in different types of methods. We could say, all right, if coin equals. Now, here's what I can also do. I know that in this case there's only 2 possibilities. I don't even really need to keep track of the tails in this case. And I could simply say 100 minus heads. I don't even need the variable tails. So I could shortcut this down quite a bit. Now, there's some advantage to using it if we're going to scale that program out. But I could make this really short and sweet because I can eliminate a lot of those pieces in there. Now that we know how to do a for loop, you could do it with a for loop instead of a while loop, and you could make it even shorter. And you could make this program really, really short. All you're doing is simulating flipping those dice a couple of times, or those coins. So you can narrow it down, because if coin, we know that there's only one other possibility. So just some ways that you could have done that, and ways to look at, and things to look at. So. All right. So make sure you have read the rest of the chapter and looked through it. We'll finish up next week, and we'll look at, or next Thursday, sorry, not next week, and we'll look at how we can build these tuples that we've talked about, which are the beginning of what we're going to call an array, and how we can deal with a lot of these elements. All right, we'll let you out of here a little early today because we have all these 8th graders, and we'd hate for you guys to meet them and be frightened by them.